Hello everyone. I am Ohtani of Nippon Express Research Institute Company Limited, NEXCO RI. We are called NEXCO and manage the highways in Japan. Today, I'll join second surface webinar with pre-recorded video. My presentation is study of calculation of road surface luminance for new pavement in Japan. We selected an out table using the measured values of the road surface luminance at the site in order to improve the accuracy of the road surface luminance calculation for tunnel with new pavement and LED luminaire in Japan. Then, I'll explain the outline of it. The contents of this announcement are as shown in the slide. Introducing the overview of Japanese highways. The total length of the roads managed by NEXCO is 9608 km. Among them, the number of tunnels 1941 tubes, and the total length of the tunnels is 1852 km. The current ratio of LED luminaires is 23% for tunnel lighting and 19% for road lighting. In Japan, new drainage pavement has been developed and is used in about 80% of the total. Drainage pavement consists of two layers, a drainage layer and a waterproof layer. The drainage layer on the pavement surface is uneven compared to conventional asphalt pavement. Explain the problems of tunnel with LED luminaire and drainage asphalt pavement. High-frequency electric ballast fluorescent lamps have been used as conventional light sources. In those tunnels, there was no problem in calculating the road surface brightness distribution using the out table C2 recommended by CIE. In recent years, LED have been adopted as standard light sources for road and tunnel lighting in Japan. In tunnel with LED luminaire and drainage pavement, low uniformity of road surface luminance may become noticeable. The factors that cause uneven luminance on the road surface are as follows. Since the LED luminaire has a luminous intensity distribution with strong directivity, low uniformity of road surface luminance is remarkable. Drainage pavement has a relatively high specularity and is considered to have different reflection characteristics from conventional dense graded asphalt pavement. Since the out table for drainage pavement has not been reviewed, the calculation accuracy of road surface luminance is low. It is necessary to make efforts to improve calculation accuracy of road surface luminance in order to ensure proper uniformity of road surface luminance in tunnel. The following examinations were conducted on the issues. Evaluate the consistency between the measured value on site and the calculated value of the road surface luminance. Evaluate the correlation between calculated maximum luminance slope and the subjective appraisal value of comfort regarding uniformity of road surface luminance on site. I will explain the lighting design method in Japan. There are lumen method and point-by-point method in the calculation method of lighting design in Japan. The lumen method is mainly used when calculating the average road surface luminance and road surface luminance. The point-by-point method is mainly used when calculating the luminance, uniformity, and the relative threshold increase. This section explains how to calculate the lumen method. The lumen method is a method of calculating the average illuminance of surface based on the luminous flux on a surface from the luminaire. Illuminance is calculated using this formula. Luminance is calculated using the average illuminance conversion coefficient defined by each road surface type. The utilization factor is calculated using the formula shown on the slide. The point-by-point method is calculated according to CIE publication number 30.2. The slide shows the calculation points for point-by-point luminance in CIE publication number 30.2. In Japan, the R table C1 and C2 recommended by CIE are used. We actually measured the luminance in the on-site tunnel. The luminance of the field tunnel was measured in the three tunnels shown in the table. The pavement of tunnels A and B is immediately after laying, and the pavement of tunnel C is 2 years after laying. All tunnels use LED as a light source, and the pavement is drainage. These are the tunnels where the measurements were taken. Tunnel B was measured while changing the luminaire spacing and luminaire arrangement. Luminance measurement was performed by fixing a luminance meter with a viewing angle of 0.1 degree at a height of 0.1 meter on the rod and depression angle of 1 degree. The measurement points are as shown on the slide. Results: we evaluated the consistency between the measured value and the calculated value. We verified the difference between the measured value and the calculated value in the A, B, and C tunnels. If the measured value and the calculated value are the same, they overlap with the dotted line. The difference between the measured value and the calculated value was remarkable in all tunnels. Since it was drainage pavement, it is thought that the cause was that it did not have standard reflective characteristics. Drainage pavement is more mirrored than conventional pavement. Therefore, I compared the measured value with the calculated value using the W classification system. Correlation evaluation was performed between the luminance gradient and the subjective evaluation value. The relationship between the luminance gradient (Ls max) calculated by W1 and W2 and the subjective evaluation value was confirmed. The design using lane uniformity UL could not suppress the uneven luminance of the road surface at the site. As an alternative to UL, the evaluation was made with reference to the concept of luminance gradient used in de Boer's study of road lighting discomfort. The luminance gradient is the maximum value of the difference between adjacent partial luminance divided by the average road surface luminance. We will explain how to observe the evaluated discomfort due to uneven luminance on the road surface. The subjects were 9 lighting engineers with driver's license in their 30s and 50s. The evaluation scale was evaluated on a 5-point scale of noticeable to good. The results of the relationship between the luminance gradient Ls max and the subjective evaluation value in the measured and calculated value are explained. The figure on the left is a distribution of the calculated values using the reflection characteristic W1. The figure of the right shows distribution of the calculated values using the reflection characteristic W2. Comparing the left and right graphs, the reflection characteristic W2 tended to have a smaller difference between the measured Ls max and the calculated Ls max. I will explain the suggestion of a new index for evaluating discomfort due to uniformity. In tunnels with LED luminaire and drainage pavement, dark areas occur near the roadside zone, so an index that can be evaluated comprehensively is desirable. The minimum value within one span of minimum road surface luminance divided by maximum road surface luminance in the road's crossing direction (UW) was investigated. The measurement points are as shown on the slide. Considering the reproducibility of the calculated value with respect to the measured value, we decided to calculate the luminance distribution using the reflection characteristic W2. We verified the relationship between UW and the subjective evaluation value from the brightness distribution data of the measured value and the calculated value using W2. The measured value and the calculated value in the measurement range show the same tendency. NEXCO have decided to specify UW as an index for evaluating the uneven brightness of the load surface. NEXCO used the existing out-table W2 for convenience when performing lighting design calculation on drainage pavement. In addition, load surface luminance unevenness is suppressed by defining transverse uniformity (UW) as an index for evaluating load surface luminance unevenness. However, there are still differences in the load surface luminance distribution. In the future, we believe that it is necessary to formulate an out table for drainage pavement particular to Japan. I will explain the next deployment. In order to develop an out table for drainage pavement in Japan, we will carry out the following research. We will collect and measure drainage pavement in Japan. To validate an out table calculated from these measurements, and to standardize an out table. Thank you for your attention.